I welcome you all to the second video lecture series for this course EC 304. In today's video lecture, we are going to quickly see about the architecture of 8051, some salient or fundamental features of 8051, so that you can understand some of the basic assembly language that I'm going to do in this video lecture. Okay, so this is a quick intro to 8051. The first and the foremost attribute of 8051 is it is a CISC processor. When I say CISC, it means complex instruction set computer. If you're not able to unravel the jargon, don't worry. During the class hours, I'll be explaining you in detail about what is a CISC processor, what is a RISC processor. So there are only two types of processors, CISC and RISC, as far as the architecture is concerned. CISC stands for Complex Instruction Set Computer. So 8051 falls under CISC category. As already told you in the class, the next important attribute of 8051 is its architecture is very simple and easy to understand. It's 8-bit microcontroller, meaning that it can handle 8 bits of data simultaneously or at an instant. That's why it's called an 8-bit microcontroller. As an added note, any microcontroller is called an 8-bit, 16-bit, 32-bit or 64-bit microcontroller based on only one factor: the size of data it can handle at an instant. If it can handle 64 bits of data in an instant, it's called a 64-bit microcontroller. If it can handle 8 bits of data at an instant, it's called 8-bit microcontroller. So the bus width or the data bus width is 8 bits here, so it's called 8-bit microcontroller. And 8051 belongs to a category of architecture called accumulator-based architecture. Okay, what is this accumulator-based? There are several architectures: accumulator-based architecture, register architecture, okay, a stack architecture. There are several architectures, of which this comes under accumulator-based architecture. Now, what do we mean by accumulator-based architecture is, if you are performing any operation over a data or over set of data, like addition, subtraction, multiplication, division, okay, accumulator should be one of the operand. For example, if you're going to add two numbers, 5 plus 2, then the number 5 should be moved to the accumulator, and then you can either add the number 2 directly, or you can move the number 2 to another register, and then you have to add accumulator and that register value, or accumulator and that number. Accumulator should be one of the operand in any operations that you perform. Okay, mathematical and logical operations that you perform. If accumulator is not involved, the compiler or the assembler is going to give you an error. Okay, so everything is accumulator based. Okay, so that's why it's called accumulator based architecture. I'll deal about this in detail in class. The next set of attributes is 8051 has 4 ports: port 0, port 1, port 2 and port 3. Okay, all of these ports have multiple functionalities. That is, apart from being responsible for input-output data exchange, they also have other several functionalities. Okay. Now, the vast instruction set of 8051 is divided, or it can be grouped into 5 heads or 5 categories: data transfer instructions, logical instructions, branching instructions, arithmetic instructions, and bit-oriented instructions. An example of data transfer instruction is any instruction that helps us to shift the data from one point to the other, like move is a very good example. MOV, mnemonic, MOV, move is a very good example of a data transfer. Logical instructions, you should all be familiar with AND, OR, okay, XOR logics. Branching instructions are the ones which totally shift the flow of the program execution. Generally, the program execution is sequential, one after the other, unless there is a decision making instruction like if then. If you take C language or higher level language, if then, or while, these are checking conditions. So whenever a condition is checked, that alters the flow of direction of execution. So those are called branching instructions. Some of the branching instructions in assembly, as far as 8051 is concerned, are it could be DJ, NZ, CJ, NE. Okay, I'll tell you the functionalities of these instructions later. Next, arithmetic instructions, you must be all familiar with it, as add, subtract, multiply, divide. And there are bit-oriented instructions like bitwise and bitwise OR. Okay. The next set of attributes is 8051 has 8 general purpose registers available for users from R0 to R7. Okay. Now, if you go to KEIL, or when I go to KEIL, I'll show you there will be a small alphabet A in the left pane of your KEIL whenever we go into the debug mode. A stands for accumulator, and there is another alphabet B that will be seen in the left pane window. When you get into the debug mode, it's called a B. It's secondary accumulator. The role of the secondary accumulator is to be like a personal assistant or a secretary to the main accumulator. Okay. Whenever we program in KEIL, we have to load some numbers to registers or play with numbers, or add numbers or subtract numbers. So we have to tell the KEIL assembler or compiler what kind of number are we inputting. Is it a hexadecimal number, or is it a binary number, or is it a decimal number? If you after the if the alphabet H, okay, succeeds the number, it's denoted as hexadecimal. If it is B, it's binary number. If it is D, it's a decimal number. Okay, this I'll show you while we program KEIL. Okay, so now we have seen some fundamental attributes of 8051 which you should never forget. Now what we will do is we'll go to KEIL and we'll try to just play with a couple of basic assembly instructions so that you'll be more familiar when you come for the lab. Okay. So as instructed in the previous video lecture, now you know how to open KEIL, how to create a project, how to set up the target variables, excuse me, how to set up the target variables, how to create a ASM file, and how to add it to your project, right? So assuming that you have familiarized yourself, practiced it, and you're well familiar with it, I'm directly going for demonstrating very simple or basic assembly level language programming. Now, as far as KEIL is concerned and this 8051 programming is concerned in assembly, I will always prefer a 3-column approach in programming. There is no wrong if you write everything in one single column, but the program will lack clarity. If it is a small program, no problem. If it is going to be a big one, it will be very difficult even for you to debug. So I'll always follow a 3-column approach, where the first column, if you see the cursor, the first column, that is this space, I will use it for writing any labels. Okay, and then the next column from here till here, I will use it for writing my mnemonics, and the third column I will use it for writing my variables or data. Okay, so I'm leaving the first column for label. I'm starting from the second column for my instruction. As I told you before, the commands or the syntax or the keywords are case insensitive. Okay, so I'm writing org0000h. Now I have already told you this specifies the starting point or the origin. Okay, now you may have a question why it should be always 000h. Why can't it be 10h, 20h, 3h, 4h, 5h? It can be any number except for reserved space. There are some reserved space for ISR. I'll tell you what is ISR. And there are some reserved space for bit-wise programming. Other than that, and there are some reserved space for special registers. Other than that, any chunk of memory, physically addressable memory can be used. But the only problem is, whenever 8051 is reset, okay, the reset vector address is 0000h, 16-bit address. Okay, so each 0 stands for a nibble, that is 4 bits. So 1, 2, 3, 4, totally 16 bits. So it's a 16-bit address. The reset vector has the starting address as 00000h. So whenever you are starting or initializing your processor, the pointer will always point to 0000h. So that is by default. So if at all you want to start from a different location, right now don't worry about it. In due course of time, I'll teach you how to start from a different location. As of now, to make things easy and for your better understanding, let's start from origin. Okay, so I've specified my origin. Now the first command I'm going to teach you is move. Move is a data transfer command which will move the data from one location to the other. Okay, so I'm going to say a comma hash 5h. Okay, so if you look at this, the first one is the instruction. I'm asking it to move. Okay, the second one what you see is the destination, and the next one what you see is the source. Next one what you see is the source. So this is the instruction, this is the destination where the data has to be moved, and which this specifies which data has to be moved. So I'm moving the number 5 to the location accumulator A, and the type of number I'm moving is hexadecimal. Okay, this identifier hash, this symbol hash stands for the assembler to understand that this is data. When I don't put a hash symbol, you see in the origin I didn't put a hash symbol. So when I don't put a hash symbol, it indicates this is not a data, this is address location. So because as far as the processor is concerned, address location, data, there is no distinction. Everything is going to be ultimately in ones and zeros. So it is us who has to specify to the processor that, or the assembler or the compiler that, what we are trying to move is either a data or an address. So here we are focusing on data. So to indicate that, I am putting this hash symbol. Okay. So in this instruction, I am moving a variable, or data 5, which is a hexadecimal number, which is not an address but a data, into accumulator. This is the command I am giving. Now there is also another form of move R0, hash to H. Now as usual, the first one is the instruction, next is the destination, and next is the source. Now you can ask me one question here. You said 8051 is an accumulator based architecture, and accumulator should be one of the operand. It is only for arithmetic logical operations that are being performed. Okay. In this I'm just moving the data, and that too this is an immediate data into a register, so that is not an issue. Now there is also another form of move which I will show you. Move A, R0. Again, if you see, this is an instruction here, destination, source. So it is the same move command, but I have shown you 3 different types: moving a data into accumulator, moving a data into a register, moving the value that is contained in the register into an accumulator. When I say move A, R0, what I am actually telling the compiler or the assembler or the processor to do is, please go to the register R0. Whatever value is there in that R0, please transfer it to A, or shift it to A, or copy and paste it to A. You get it? And finally, I am saying end. So please remember, instruction is always followed by destination, is always followed by source. Okay, now let us save it and build it. As usual, I'm getting 0 errors, 0 warnings, so the program is clear to go. So what do? We go to the debug menu. This is what I was referring to. Remember, I told you when I was showing you the PPT, I was talking about small a and small b. Do you see this? So this is the accumulator, and this is like a supporting accumulator or a secondary accumulator to help this main person. Okay, and this is the registers R0, R1, R2 up to R7, 8 general purpose registers I was talking about. Now as usual, like in the previous video lecture, this double arrow indicates the statement that is going to be executed. So what do you expect to happen when this statement is executed? Good, correct. This 5, which is a hexadecimal number, will be moved into accumulator. So initially, what is the accumulator value here? Yes, 0. So after the statement is executed, what should happen? This value should be replaced by this value. So shall we just step in and see what happens? Yes, as expected. If you see here, 0 was replaced by this 5H. Okay, now what is the next instruction? Move R0, hash 2H, that is 2 hexadecimal number. So what do you expect to see? This R0 content, which is 00, will be replaced, or this 2 will be moved into the register R0. Shall we see what happens? See, when this statement is executed, R0, which earlier had 0, has been replaced, or this value has been copied into R0. Now what is the next statement? Move A, R0. What does that indicate? Go to R0. Whatever value is there in R0 should be copied and pasted in accumulator. So what is the value there that is there in R0? 2. So this 2 will be copied and pasted in the accumulator. When such thing happens, what do you expect to see? This 5 will be erased, and finally 2 will be pasted here. Okay, so it is an 8-bit register. Accumulator is an 8-bit register which can hold only one 8-bit value at a time. You cannot make it hold both 5 and 2. That is the concept of register. This is how registers and memory differ. Memory is collection of registers. If there are 10 registers put together as a memory, that means we can have 10 8-bit values in that memory. But accumulator is only a single 8-bit register, so it can handle, or it can hold only one 8-bit value at a time. So it can either hold 05 now, or when this command is executed, this 02 will replace 05. Let's see whether that happens or not. You see now, the 5 is erased, and instead of that 2 is overwritten. So it has moved the value in R0 to accumulator. Now if you see the beauty here, the value in R0 is retained. It is not cut and paste operation, it is copy paste operation. Understood? So this is how the move function works. Is that clear? Okay. Now let's go back to the program. Okay. I'm going to do a very simple thing. I'm also going to make this 5H, and I'm going to show you a simple arithmetic operation. So what does the first two statement tell you? It instructs the processor to move the value 5, which is a hexadecimal number, into A, then move another value again, which is also a 5, an hexadecimal number, into R0. Then instead of moving, now I'm saying add which two? The value in A and the value in R0. Excuse me. Okay, but this doesn't change. See, the instruction can change to move, add, and, or, XOR, whatever, but the sequence is the same: instruction, destination, source. So according to that, what am I instructing? We have to add two numbers, A and R0, and where should the result be stored? The result will be stored in the accumulator. Okay, no matter what the sequence is, even if I write R0, A, the result will be always stored in the accumulator. So it is accumulator centric. That is why we call 8051 as accumulator based architecture. Shall we try it? So I'm just compiling it again. No errors as usual. I'm going into the debug mode. As usual, I'm executing the first statement. So accumulator got 5. Now in the next statement, R0 should also get 5. Done, right? So accumulator got 5, R0 got 5. So when I add these two numbers, what is the result? 10, correct? See, it is represented as hexadecimal number. It is stored in the accumulator. So the previous number of 5H, which was stored in the accumulator, now will be erased, and you will have the result here in the accumulator as 0A. A is the hexadecimal equivalent of decimal 10. Now does this happen only when I write H? No matter whether it is B or H or D, internally these are represented always only in hexadecimal numbers. I'll show you that. I'm writing D here to indicate it's a decimal number. Compiling it. 5, still A. Why this shows 5 and 5? Because from 0 to 9 hexadecimal and decimal there is no difference. Only from 10 the equivalent changes to A, B, C, D, E, F, and so on. Okay, I'll show you, if you want to see, I will also show you an example like that. Okay, I'm going to show you 10D. Let the number be 10D. See now what is being loaded in the accumulator. So I'm writing 10 decimal. So when I run the first step, see, A, 10 is converted to A. Now when I run the second step, 5 is loaded. The same 5 because decimal and hexadecimal, they are the same. Now when I add these two, result is 15. So instead of 15, you will see, what is the hexadecimal equivalent of 15? Correct, F. You will see that here. It will show as 0F. You got it? Understood? Fine. In the next video lecture, we will talk more about data representation in KEIL. How to write a 4-bit number, binary number, decimal number, hexadecimal number. Okay? Thank you.